Good morning, friends. I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. I am in the process of the next course, which is aircraft systems. As you know that previously I have covered the aircraft stability and control. The total course is covered and it is available on YouTube. Anyone interested to understand about aircraft stability and control, you are welcome to visit IARE website and YouTube. You just copy or type IARE Yagya Dwivedhi. You will get my YouTube videos. Please go and see these videos and you will get some knowledge about aircraft stability and control. In this course, which is aircraft systems, today I am in the lecture number 2, and in this I am going to discuss about airframe and structural system. In the previous class, I have gone and discussed about something, introduction to the aircraft systems. There we have divided the aircraft systems in number of parts. This I will be covering in revision topic. Then I will go for introduction to aircraft system. Then airframe and structural system. In airframe and structural system, we have 3 major areas of airframe and structure, that is wing system, empennage system and the fuselage system. If you see here, I have here a model of the aircraft, and in this model if you see, these are the wing. 2 wings, left wing and the right wing. Then the second is empennage, this part from here, tail, this from here to here, vertical fin or the vertical stabilizer, and then horizontal stabilizer. Horizontal stabilizer consists of elevator and the trims also. Your vertical stabilizer or the fin consists of the vertical stabilizer plus a rudder. If you see here, this I have shown here, this is the rudder. Wing is here. This wing consists of so many parts that I will be discussing, but mainly it consists the ailerons here at the tip, and at the root we have the flaps. This you can see, flaps and the ailerons. The main part is this fuselage, where all the peoples, all the materials, fuels, everything is kept, and where the space for the passengers, for the air crew, for the pilot, everything is maintained. It should be maintained with a proper atmospheric conditions so that it is comfortable to the passenger, and also it is very good for the avionics and other equipments used in the aircraft. So these major components, I am just giving a brief on that, but in this class I will be discussing in detail about all these systems which are used in this course. So here we have one about operation of the system, and this you can see here. Just I am going to show you one small video, and by this video you will understand that what type of systems are used and how these systems can be understood very well. Okay, so here just it is explained that the aircraft structure is a semi-monocoque structure, and here we will see that these semi-monocoque structures, you can see here landing gears. These are the landing gears of the aircraft. This is called the tricyclic landing gear. we have one nose landing gear and two are the main landing gear, and these are the oleo struts where a hydraulic device is fitted, and these are the wheels. There is a hub. These wheels are also equipped with a brakes. These brakes are operated by the pilot who is sitting here on the cockpit, and this aircraft, we can see that how this aircraft is working. This is a semi-monocoque. This is the configuration of the fuselage. If you see here, the fuselage is not a one piece. It is number of bulkheads, longerons, and all things are here, and it is hollow. So this type of systems are called the semi-monocoque, and this you will see here. Now you can see the wing here. This you can see here. These are the wings. If you see the wings, you have so many parts here. Every wing is made of the here aerofoils, and from here front longerons, and this is the rear longerons. In between you have so many other things that is called the stringers. And here, if you see this horizontal tail, in horizontal tail also we have the airfoil 1, 2, 3, 4, and here also when small longerons are here. Here also the vertical longerons for the vertical fin, and they are divided in number of parts, and above that skin is fixed. So you can see this fuselage. Fuselage is a skin, monocoque, semi-monocoque structure. Wings are made of longerons, stringers, then number of airfoils, and it is covered with a skin. And skin should be very smooth, and same way all things are covered. This you can see the flow of air over the wing. Here you can see the air is moving from here to here, from this leading edge. It is called the leading edge of the wing, and then it goes to the trailing edge of the wing. And if you see, the smoothness of this airflow is disturbed, and here you get some disturbance, and it is called the vertices, trailing edge vertices. And from here to here it is a aileron, and the flow is passing from here to here. Here this you can see, it is a conventional landing gear. Previously you have seen the tricyclic. Now this is called the conventional landing gear. In conventional landing gear, you have the two landing gear at the front and one at the this tail, very much near the tail. So what is the benefit in this? The benefit of this thing is the space from ground to the propeller is increased, so that you can use a longer propeller for this type of aircraft. But it has got some disadvantage, that the tail part may hit the runway or the ground during landing and all. So damage are likely to happen if like this tails are used. Now this engine is started, propeller is moving. Now you can see, this is now the next part is empennage. You can see a arrow, the behind one is an arrow, and these things are called the empennage. If you see here, from here to here, these are called the empennage of the aircraft. In this empennage, we have the horizontal tail here, two horizontal tail, left and the right, and behind this horizontal tail, we have the elevators. These elevators are used to make nose up and down. This is called the vertical fin. This is called the vertical fin. In vertical fin, you have the rudder here behind. The rudders are used for yawing left or right. Here you can see there are some antenna, and this is called anti-collision light. The anti-collision light is fixed because if any aircraft is behind or above or below to you, you can see that any object is flying. So it is a red color and it is flashing intermittently. And this intensity of this light is very high, so it can be visible for very longer distance. So that is the benefit of this anti-collision light. Here you can see these are the static discharges. These static discharges are used in the control surfaces and in the wing and these things, so that if any static electricity is formed due to the friction between air and the body, this static electricity can be discharged by these methods. Okay, so this you can, it is shown, it is a horizontal stabilizer. This you can see, it is a tricyclic, and this is used for shock absorber. These things are used for the shock absorber, and this you can see, this is the tricyclic and another is a conventional one. And why it is called the tricycle? This you can see, here is the cycle, one is the nose and two are the main. By this it is known as a tricycle. And rickshaw, we are telling rickshaw type. Okay, how this aircraft is landing, you can see here, and how these propellers are rotating. And you see, this is the conventional. In this, your one wheel is at the tail and two are at the front. Pilot is here. So the problem is this, your visibility is somewhat reduced. That much height is increased here. If it is not like this, your propellers may hit on the ground and you cannot use a bigger propeller. Now you can see this, it is a conventional, and how this is. Now the next part is the power plant, means engine. These engines may be the IC engine, piston engine, or the rotary turbofan engine, turboshaft engine. So here we are showing the reciprocating engine. These engines are working as a piston and the cylinder. Two engines, both are the propeller operated, and these things are, how these things are happening, you can wait, and how these engines are working. This you can see here. It is rotated, engines are rotated, you know the principle, and these propellers are rotated by the help of the engine, and these propellers are trying to push behind the air, and you can have two-bladed, three-bladed, or the four-bladed propellers, and it can be variable pitch or the fixed pitch. Here it is shown the variable pitch propeller. To increase or decrease the speed, we need the variable pitch. So engine speed will be constant, but your propeller pitch will change. Okay, so I am going for the next. Okay, so now I am going for the revision of the yesterday's class. That is the, what is an aircraft? A vehicle that flies through lift from air is called the aircraft. Origin of this word aircraft is from the Greek. We have the aircraft systems and subsystems. In this we have the airframe system, vehicle system, avionics system, and the mission system. These systems are airborne aircraft systems. For safe operation of these systems, if you want to fly our aircraft for a safe, these all systems to perform very well, and they should have very good coupling with each other. They should have very good understanding, and they should perform as per the requirement of the aircraft, so that aircraft can fly safely. Further, we have given here a block diagram. In this block diagram, you can see that the four systems which I have mentioned above, that is the airframe and structure system, vehicle system and avionics system, and the mission system. These are explained in the next slide. So the revision of introduction of aircraft systems. This you can see here. This is the revision of introduction of aircraft systems. So this is the system which I have shown in the last class also. So if you see here, we have here some key elements here. This is called the ram air, then bleed air, then fuel system, hydraulic system, electrical power system, engine oil system, fan and cabin air. You can see the color. If you see this ram air, the color is this. Ram is nothing but when aircraft is flying. If you see, this aircraft is flying like this, and due to this velocity of this thing, air is stacking here, and due to this stagnation of this air, a high pressure is generated. So it gives a high pressure due to the sticking of air on the aircraft. This air is called the ram air. This ram air is used for the cooling of the aircraft, for cooling of the aircraft systems that I will explain, and also to operate the wind turbine, so that emergency electrical power can be generated if the aircraft main power generation system, that is the alternator, is failed. That time pilot will lower this gas one turbine like this, or it can be made up and it will rotate. Due to this wind effect, it will rotate and it will generate a power, and this power will be given for emergency supply of the different aircraft systems. Now you can see here that we have here ram air, bleed air, fuel, hydraulics, electrical power, engine oil, fan, cabin air, avionics. Okay, so if you see here, I will start with the ram air. First one is the ram air. Okay, you can see here. This is the ram air. Okay, you can see here. This is the ram air. Aircraft is flying in this direction. So your ram air will move in this direction. This is the ram air. So you see the, okay, next here is a bleed air. Bleed air is taken from the engine, especially from after few stages of the compressor, and from there it is becoming some high pressure air, and the temperature is also increased. This bleed air is taken from here. It goes to a air cooler, and from here fan casing also it goes, and from here this air goes to the air conditioning unit. The air conditioning unit is rotated. It is like a turbine. This turbine is rotated, and this will give some high pressure and high temperature, or it can reduce the temperature. Okay, so this high pressure and high temperature is here, and it will reach to the air conditioning. This high pressure and high temperature will be reduced, and it will be the cold, and this cool air with the required pressure will go to the mixing plenum chamber, where a hot air is coming from there bypassing. Both are mixing. There is a regulator. This will regulate the temperature and the pressure as per the requirement of different passengers or the avionics equipment. Okay, this plenum, and after that it goes to the avionics and the cabin where passengers are sitting, and they are, and even this all avionics equipments are fixed. If you talk about the fuel system, it is a very important system. Most of the fuel is stored in the aircraft wing. From here, if you can see, it goes from here to the engine, one line. But if you see, there are different other lines which are going. This is the hydraulic system. From the hydraulic system, oil is cooled by the help of the fuel, and this fuel is passing, and it is cooled by the help of air as well as by the fuel. Same way, this ram air is used here to cool the engine oil system. This engine oil is sprayed inside the engine bearings, and these bearings are a very high temperature. These high temperatures are used, and to cool this oil, first air is used, then after that some part of this oil is cooled by air, and next part it is going to another heat exchanger. In this heat exchanger, air is also blowing and fuel is also coming from here. So this fuel is heated up little and going to the here. Further, this fuel we have to again cool it, because if the temperature of the fuel is increased from a limited amount, fire may take place. So this a separate cooling system. It is only air cooling is used, and in this way the fuel is also cooled. So now we have completed ram air, bleed air, fuel, hydraulic system. The hydraulic system is used to operate the landing gears, your control surfaces like rudder, aileron, elevator, flaps, spoilers, also opening, closing of the door, and so many other components are operating by help of the hydraulic system. We also have the electrical system. This electrical system is also mounted, the alternators are mounted on top of the engine. Your hydraulic system is also mounted on top of the engine. The rotation of this engine is transferred to these pumps and this electrical alternator and hydraulic pump. And this electrical alternator also has to be cooled. Okay, so this is cooled by help of the oil, engine oil. Okay, just you see, engine oil is coming here and this has to be cooled. And so in this way, cooling is essential. Then it is a electrical power. This power is going for all the equipments, lightings and all things. It is supplied. Then last but not the least, it is a fan and cabin air conditioning, because passenger need a proper air circulation. They need a proper temperature. They also need a proper pressure so that they should be able to sustain in the fuselage very efficiently. They can work nicely, and all the avionic equipments which are operated by the pilot or observed by the pilot has to be work properly, so that these avionics systems are also used. And in this avionic and the cabin, if I talk about the cabin, it is a pilot, that is the pilot place, and also the passenger place, that is the cockpit, as well as the passenger places has to be pressurized, has to be cooled, so that a comfortable condition is maintained. So this I have shown a simple aircraft systems. In this all the basic systems are covered. However, the advanced topics we will be covering in due course of time as and when their module is coming. Now here it is a new one. This I have explained yesterday. From here onwards it is airframe or structural system. In airframe and structural system we have the wing system, empennage system, fuselage system, and I have shown in the video also that what is the wing system and what is the empennage system and what is the fuselage system. Okay, this is the made by our student, and this you can see here, these are the wings. Here also if you see, the wings are made of airfoils. These are the air 1, 2, 3, 4, and here also you have everywhere you have the airfoils. These airfoils are wooden made, and as per the requirement of the aircraft lift, different airfoils are used. And here we have the longerons. These longerons are the main component those are taking the total load of the wing. Wing is experiencing a lot of bending loaded and all the different types of load. This all has to be all the bending loaded and all other loaded has to be absorbed by this longerons. Okay, so like this we have to see it. And this longerons are also supported by the different other things. Okay, so stringers are there, small strips are there, stringers. If you see this, so like this we have the wings, and these wings also having the skin is made so that it is very smooth. Here is the ailerons, left and the right. These are the ailerons are moving in opposite direction. If this is moving down, it means it will go like this, right? If your this, just you can see, if you want to make this thing down, So this has to go down. This aileron has to go down and this has to go up like this. It will move in this direction. And opposite can happen in this way. So like this, we have to make sure that our wing system is as per the design requirement. Before that, we have to do so many calculations, so many simulations before fabricating of the wing. Next is the empennage system. If you see here, in this I have shown here, this is the wing system, and here from here, this part, if you close this is the empennage system, and here we have the horizontal tail, vertical tail, elevator, and the rudder. These are the major part of the empennage, and this is called the fuselage. In this fuselage, here it is called the cockpit. In the cockpit, pilots are sitting, and these are the main doors here and here. Two doors are there. These passengers and pilots will enter from here also. This is the engine. Most of the time, engines are fixed in the wing itself. The fuel is also accumulated in the wing itself. Most of the 90% to 95% fuel is accommodated inside the wing, and some 10 to 15% these things are accommodated at the belly of the fuselage. The fuselage is basically used to accommodate the materials and the personals and all equipments which are used in the aircraft. So here we can have a classification of the aircraft systems. So here aircraft, here we have the airframe and structural system, then vehicle system, then avionics system, then mission system. In airframe structural, we have the wing, empennage, and the fuselage. If you talk about vehicle system, we have the fuel system, propulsion system, flight control system, and hydraulic system. If you talk about avionics system, we have the navigation control, we have the displays, we have the communication. This is called the avionics system. If you talk about the mission systems, we have the sensors, mission computing, and the weapon system, and also some more missions are there. Different aircrafts are designed for different missions, but particular for a fighter aircraft, they have mentioned the weapon. If you see some other aircrafts, they are used for the search and rescue, for the anti-submarine warfare, or different types of missions are there. Every aircraft is designed for some missions that has to be completed by the particular aircraft. So this is here given a brief idea of the different aircraft systems which are used in the aircraft. This all verticals, 1, 2, 3, 4, it contains one unit. So in detail, we will be discussing in different units. That time, we will go each and every in detail. But as of now, I am going with the first vertical, that is the aircraft structural system, which consists of wing, empennage, and the fuselage system. Here I am showing some part of the aircraft. It is very much essential that before we go for the in detail about aircraft systems, we should understand what type of parts are used in aircraft and why it is required. Okay, so I will start with the nose. So this is the cockpit here. In cockpit, we have the command and control. Command and control is obtained by the pilot. One or two, mostly two pilots are sitting in the passenger aircraft. But if you take the fighter aircraft, there is only one pilot. And for a trainer fighter, you may have the two pilots. Here we have the fuselage. The purpose of the fuselage is to hold things together, carry payload. Then here we have the slats. The slats are used for increasing the lift of the aircraft. During landing and takeoff, we want a higher lift. That time these slats are operated. Then we have the spoiler. The spoilers are lifted up, so they change the lift, drag, and the roll of the aircraft. Here we have the aileron. Ailerons are at the tip of the wing, at the trailing edge. They are used for the changing the roll position, increasing lift and drag. There are the flaps. Flaps are used to increase the lift and drag. Here is the elevator. Elevators are used for the making nose up and nose down. Then we have here vertical stabilizer. This is the control yaw, stabilizing the yaw. And this is the rudder. They change the yaw. So that is the difference. Stabilizers are used for the stabilizing, but controls are used to control or change the position where it is existing. Horizontal stabilizers are used for the longitudinal stability, and the vertical stabilizers are used for lateral and directional stability. Here we have the winglet. The winglets are nowadays used from last 20 to 30 years. Most of the passenger aircrafts are equipped with the winglets. These winglets are decreasing the drag, especially the induced drag. The induced drag is happening due to the pressure difference between lower surface and the upper surface. And the lower surface, if you see here, just I will explain. The winglet, if the winglets are here, like this, here the pressure is high and upper side pressure is low. So as vertices are formed from tip, it will go like this. Both sides, it will rotate like this. This will generate the induced drag. Additional induced drags are generated due to the pressure difference between the bottom and the lower and the upper surface. And so we need some thing. So a small strip like this, we have to fix. That is called the winglet. These winglets will not allow to circulate. Air will go like this and it will come. It will not make a circulation. So the purpose of the winglet is to decrease the induced drag. Now wings are the primary lift producing component. This you can see here that this yellow color, orange color, these are the wing, and here 90% of the lift is generated by the wing. Then we have here the turbo engine. This you can see here. This is the turbo engine. If it is a propeller will be here and it will rotate like this. Propeller engine can be used for the piston engine and also can be used for the turboprop engine. Jet engines, turbojet engines are used for the jet. Turbo fans are used for the for generating additional efficiency of the aircraft, consumption of the less fuel. These are the advantages of the turbo fan engine. So in this way, I have covered all the components which I have discussed till now. Now, I will go with the airframe systems. And if I talk about the airframe, this you can see that if no wing, just you can see here is the wing, this is the wing. Okay. This part is wing and this I have shown, this is the engine. From here to here, this is the wing. Okay. So wings are very much required. This is the center of the wing and this is called the longerons, front longerons. This is called longerons. Okay, and this is the rear longerons. So this is thick metal rod beam is moving from here to tip and most of the load is carried by this wing. So here if no wing, no lift. Lift L, drag D and nose down. Pitching moment. If it is pitching moment, so if lift is there, drag is there, then more lift, and if the CG is ahead of the, if you see here, this is the wing, lift is here, and if the CG is here, nose will be down. Okay, so it is explained. Design requirement, we should have a better performance of the wing. The wings are also used for stability and the control. They are also used for the operational requirement. Cost of the wing should not be very high. Flight safety has to be maintained. Without flight safety, nothing can be done. Just I want to discuss about each and every part here. You can see that this is called the front spar. This is called the front spar, a big material, a thick material. Then it is called the rear spar. This is the rear spar and this is the front spar. In between you have the stringers, small, it is moving, it is called the stringers. They are called the ribs. Small things in the perpendicular, in the direction of aerofoil and supporting the load of the aerofoil. That is called the ribs. 1, 2, 3, 4. It is shown here. They are called the ribs. And here they are called the stringers. Stringers are small rods. I have shown here. This you can see here. These are the front spar. Here and these are small rods. Number of rods like this. They are called the stringers. Stringers are the less thicker than the spar, and the distribution of the load they will transfer to the spar. So that is the purpose of the stringers. The direction of the spar and the stringers are the same. However, the ribs are the perpendicular to the stringers and the spars. That we can see here. If you see here, this is the aircraft A340-500 aircraft, and here black color is a wing. This is the fuselage. Here this is the empennage. This part is empennage, and this is the fuselage. I am writing FL. This is the empennage, EMP, and these are the wings. So if you talk about the wings, okay, how many parts are there? Just you can see, I will go one by one. Here is the wing tip. In the wing tip only we fix our winglets. Here is a slat. Slats are nothing but high lift devices. They produce the high lift as and when pilot is operating a lever. From that lever, these slats will come out. Slats are like aerofoil like this. If this is the wing slats will come out like this. Initially they will be inside here, but as and when the pilot is applying, it will come out. Air circulation will start like this. So additional lift will be generated. So the purpose of the slat is to generate the additional lift. Leading edge and trailing edge, the front part where air is attacking first. Okay, this you can see here. This is the, if aircraft is moving like this, the wind will come from this direction. So from where the first air is hitting, that part is called the leading edge, and from where air is leaving the wing, that is called the trailing edge. We have the spoilers here. Spoilers are used to spoil or reduce the lift and increase the drag as and when, especially during the landing. Then we have here center wing, exterior plate, doubler here. You can see here, these are to generate the additional strength. Then we have the trailing edge, inboard flap. We have the two types of flap, inboard and outboard. Inboard flap vane here. Spoilers are here. Inboard ailerons are here. So here we have inboard ailerons and outboard ailerons. We have inboard flap and we have outboard flap, means it is two flaps and two ailerons are in each wing. For all modern aircrafts to have a better control, and most of the time these outward ailerons are becoming ineffective due to the circulation of the wind near the aircraft. So this we have to ensure that this should not happen, and aircraft should. So outboard aileron may be ineffective in a high angle of attack flight, or whenever the more circulation taking place, that time inboard ailerons will be effective. That is why in a passenger aircrafts normally we have double safety. That is, one is the inboard flap, another is inboard aileron, then outboard flaps and the outboard ailerons. So I have explained this all the items. If you see one section of the wing, a typical transport wing, you can see here is a flap. Then here is a flap vane. It is a vane, means a passage of air. Then here is a spoiler. This is the rear spar, and here you have the front spar. A front spar is a very thick plate like this, and it will go over the whole wing like this. Okay, it may be I section or square section, but rear one is not that much, but half of the thickness, it is a rear spar. Slat track can, here slats are put inside, and this can be made up and down. Here slat track, slat here, this I told you just now, it will go out. This slat will go like this. So additional area will be generated, the flow separation, it will be avoided, extra lift is produced, it generates additional kinetic energy, so that it goes from here very smooth and the flow separation is reduced. So these are the parts of the wing, and I have discussed in detail. Hope you might have understood very well. Now I will go for the next system. It is called the Empennage System. If you talk about the Empennage System, we have from this model, this you can see here. This is the fuselage, these are the wing. Third major component is a empennage. So if you close from here, this part, whatever is visible from here, this is the empennage. Empennage, we have some part of the tail, we have the horizontal stabilizer, these are the horizontal stabilizer, we have the elevator, both sides, these are the elevators. Here we have the vertical fin, here we have the rudder. Okay, so these are the major component of the empennage. However, in detail, I am going to explain in this slide. If you see here, we have the tail part. This is the tail part here. In this tail part, we have the horizontal stabilizer. This you can see here. We have here a elevator, and every elevator is equipped with trim tab here. This is the vertical stabilizer. This vertical stabilizer is equipped with rudder, and this rudder is also equipped with a trim tab. The purpose of elevator is to make nose up or down. If you make the rudder down, then what will happen? This will go up, it will go down. If you want to make rudder up, nose will go up. So rudder and the nose is directly related. If you want to make nose up, rudder will be up. If you want to make nose down, rudder will be down. Same way, if you want to make nose left or right, if you want to make nose left, the rudder will move towards the left. If you want to make nose right, your rudder will go to the right. Okay, so elevator and the rudder, they move in the same direction. However, ailerons, they move in opposite direction to each other. That is the difference between these. Now I will go in detail about the empennage system one by one. So here, this is also generating somewhat lift. Stability and trim also can be achieved. Control and balance of the aircraft can be done. Okay, so you can see here this horizontal tail is also generating some 5% to 7% of the lift. Control is obtained, and this is also basic objective of this empennage is to give the stability and the trim. And here I have shown the trim tab. Okay, so if you see here, about this is the fin tip. Okay, here this is the fin tip. Then this is called the leading edge. If you see here, from here to here, this is the leading edge of the vertical stabilizer. Then we have the leading edge auxiliary spar. One spar is here. Here also we have the spar. Front spar and the center spar we have. If you see here, here we have the access door here. Access door 1. Then inter-spar structural access doors. If you want to see the inside any defect, any problem, any maintenance issue you want to solve, there are doors you can open. They are mounted with a screws, blind screws. It will not be visible by the star screw. You can open. These are the doors. In this you can use. Here is a rudder. If you see, this is the rudder at the trailing edge of the vertical stabilizer, we have the rudder, hinged shroud door we have, then we have the rudder flight tab, then we have the rudder trim tab. So everything is there. The rudder trim tabs are used for the trimming of your rudder on the ground. Okay, if you see the horizontal stabilizer, we have here, I will start from the dynamic balancing boom here. Then we have the elevator flight tab here. Then we have the hinged shroud door. This is the elevator behind, rear spar. This is the front spar. Then stabilizers trim screw jack. Here we have the screw jack. So it will be trimming by this vertical stabilizer to fuselage attached hinged. So in the fuselage, these things are attached. Okay, so these are some important parts of the vertical and the horizontal stabilizer. Also, the total empennage of the aircraft is explained in this diagram. Hope this will be very useful, and try to understand the objective and the use of each and every parts which are shown in this diagram, and try to understand its concept and why we need such type of arrangement. Now I am going for the fuselage. The fuselage is a major part of the aircraft where passengers, cargo, avionic equipments, all the facilities has to be accommodated. And this is biggest part of the aircraft. And this you can see that how much percentage of the aircrafts are shown here. If you see this plot here, so here it is aircraft 747. This aircraft can carry more than, it is a double decker. 2 fuselages are here. Okay, like this. So this is a single one, but from here another deck will come like this. So here plus here. So it is shown here, double decker here, big, more than 400 to 500 people can be carried. Next is the DC-10. This is a 777. Here is also, it can carry some 300 passengers. Then Airbus 300, this can carry some 200 passengers. This Boeing 767, nearly 200 to 250. Then BAE 146, Airbus 320, some 180 to 185, 190 passengers it can carry. Fokker 100, MD-80 and DC-9, they can carry some nearly 100 passengers. So these are shown as per passengers and different types of fuselage. These are the cross section of the fuselage. So we should be very much clear that this type of fuselage are used for this type of configuration. Now we have Airbus 380, and this 380 and all can carry a huge amount of passengers, and very soon one more aircraft is coming. It can carry 2,000 passengers. So day by day the technology is developing. The number of passenger, as much you have the more number of passenger, that much flying cost, the passenger ticket cost will be reduced, and so more and more passenger can travel in air. That is the objective, to increase the size of the aircraft. The operation cost of the aircraft will be reduced tremendously as much your number of passengers are increased in the aircraft. Now I want to show about the fuselage. Fuselage can be divided into the 4 major sections. First one is the forward section, then mid section, then aft section, and this is called after body section. In the forward section, we have the flight station, forward pressure bulkhead. This you can see like a nose. Here your pilot's cockpit is situated. This is the first floor here. This you can see here in this. These all are the windows. So here also these windows are shown. So in each window there are rows of passengers. In this they are sitting on the inside the fuselage. Then we have the flight station here. Then forward pressure bulkhead. Here we have the door. From here your pilots and passengers will enter. Then it start the midsection. In midsection you have the fairing, wing center. Your wings are attached in this zone, and this you can see here, wing center. It is fixed. The wings are fixed at the midsection, both sides. Okay, so here you have the keelson. It is called the keel of the aircraft. All wings, full highest body or the highest toughness and strong point is in this area. Okay, so this is called keelson. Very, very high, tough part. All loads are transferred in this area. That is the where the wings are fixed. In the wing only, if you see your landing gears, okay, that much part is also fixed. This is the aft portion. Here we have the aft pressure bulkhead. Then we have the fuselage after body. In this after body, all the horizontal stabilizer, vertical stabilizers, radar, elevators are fixed, and they are used for this purpose. If you see this diagram, in the wing, the lift is generated, the thrust by engine, drag, and the moment. Everything is generated mostly by your wing, and your thrust means engine. Engine is fixed on the wing. So the wings are generating lift, wings are generating moment, wings are generating the drag. Even the whole body is generating, but engine is mounted on the wing. So and also your landing gears are also fixed on the wing. Wings should be very, very tough, very, very hard, very, very powerful, and very much strength, because most of the loads are coming from the wing only. So it is fixed in the keelson. It is shown here. Keelson here. This is the keelson. Highest or toughest, strongest point on the aircraft is called the keelson, where your wings are mounted. If you see the horizontal tail, if it is lift is up, it is making down, so it can balance the weight of the aircraft. And here it is shown the stringers. Stringers are small strips. Those strips are supporting the aircraft bulkheads and the wings, different ribs and other things. So these are the references which I have taken from Moyer, I and Seabridge, aircraft systems, mechanical, electrical and avionics subsystem, professional engineering, publishing limited, London, and Bury St. Edmund, UK. This is the address. The second book I will be taking for design and development of aircraft systems and introduction, AIAA education series, AIAA 2004. This is the books which I am referring, and this may be useful for you also. If any questions related to this topic, you are welcome to send the mail to yddwivedhi@gmail.com. So you are welcome to ask any questions. I will try to reply. And thank you very much for this class. Please be tuned for the next class. I will be taking a very in-detail study of systems, other things used in the aircraft in due course of time. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.